Hello everyone. We are Team Scriptor. Our team ID is 52810. Our problem statement ID is SIH25050. And our problem statement is traffic congestion management in Odisha, which was given by government of Odisha. And the problem statement here, which has basically we have given a solution. We have come up with a solution, and this is the flowchart for the solution. Basically, the Earth solution is divided into two parts where the input will be taken from the camera for two servers, and server one, basically the second server is the main server which reduces the traffic congestion. Here we detect the traffic, and for detection of traffic, for invisible traffic, we are using Google Maps API. And once we get Google Maps API, we will be able to get 100-meter range from the signal and a range of traffic which is red, orange, or green. Depending on that, we will take the further decisions. And the lane detection will be done by Keras. Basically, Keras models will be uh, trained to detect lanes. There are two lanes on each road, and if there are four roads, then there will be eight lanes. Basically, a single lane will be in single direction connecting with two roads divided by the signal. So that is the logic behind it. And on each lane, once the camera detect gives out the input for a road which has two lanes, those lanes will be detected by Keras model. And the vehicle on every vehicle on each lane will be detected by the YOLO model. So this vehicular volume will be calculated, and once we compare it with the next lane for green light, which is if the round off is in clockwise direction, and once the east and once we go to the east, south, west, and north, what happens is if we go in this like clockwise direction, after the south lane is done, the south lane will be compared with the west lane. And in this format, what will happen is if the whichever lane has more congestion, basically, if of course there is a threshold that if the threshold is 30, and if there is more vehicles, more than 30 vehicles on the south lane, then it will be compared with the west lane, which will have around, let's say, less 25 vehicles, which is less than threshold. So it can have predetermined time, but we have to increase time because there is 40 vehicles in exemplary 40 vehicles in the south lane. So what will happen is uh, the green light will be increased by 10%, and then the green light for the west lane will be decreased by 10%, making it easier for congestion on the south lane to clear up, and also making it easier for all the vehicles to clear up because there are lesser vehicles compared to the threshold. So this will reduce the congestion of vehicles on both the lanes, helping in format. And if the threshold is less, if comparatively on all the both comparative lanes like south and west example which we have taken, if the vehicles are less than the threshold, then their predetermined time will be used. And here we have server 2, which is the accident detection model. If the traffic congestion is caused because of accident, then the Keras model will detect that accident. If there is fire or the deformed vehicle on the lane or somewhere near the circle, this will be detected. Accident once detected will send an SOS alert to the nearest hospital and also to the police officer if the ambulance is arriving. And if the ambulance is not arriving, then it will reinitiate the process. Basically, this is done by SMTP, and also not only SMTP, we are using an SOS link as well. And secondly, this entire process can be on and turned off through the traffic police officer. It will have control to the traffic police officer present. If there is no traffic police officer present, the control room can have the control of turning on and off for this entire management system. So what happens is this will help out in clearing out congestion, and also there will be a flexible option with the traffic police manager. Secondly, here I'll explain what is that we are actually doing. So basically, let's say there is an clockwise direction and there is 240 seconds of green light for comparing 60 seconds this lane, 60 seconds this lane, then 60 seconds for this lane, and in all 60 seconds for four roads, and which is 240 seconds, right? We have to maintain this markup. So what we will do is For example, let's say there is too much traffic here, which is more than control, and next is this one. So what we are going to do is the increase this part, this green signal time for this lane by 10%, which is 6 seconds, and reduce 6 seconds from this lane because there is less vehicles comparatively. And similarly, if the traffic is detected through GPS, which is the range and not accurate actual number, what we are going to do is increase only by 5%, which is 3 seconds, and comparatively we'll reduce it from the next lane. And also, if there is equal vehicles, then their predetermined time will be used because it is unfair for the other lane as well, which is a point to make note of. Thank you very much.